Hello everyone, my name is Tae-Gwan, a PhD student in KAIST. Today I'll be presenting our work on enhancing creative generation in stable diffusion models. This research was conducted in collaboration with Neighbor AI Lab. Let me begin by introducing the motivation behind our work with an example. Imagine a chair designer using a generative model to find fresh inspiration. Then they prompt the model to generate images of a chair. The model responds as expected, producing a series of chair images. However, what the designer truly seeks is not just any chair, but something more original and creative. A common first attempt might be to modify the prompt by simply adding the word creative. But here, the question is, does adding the word creative to the prompt actually result in more creative chair image? In our experiments, we found that simply adding the word creative does not greatly improve the creativity of the generated image. To test this, we focused on Stable Diffusion family, a lightweight, open source, and widely used text-to-image model which is well suited for controlled experiments. While Stable Diffusion performs well in terms of image quality and text-image alignment, it falls short when it comes to generating truly creative outputs. We observe the same trend even in its distilled variants, which are optimized for efficiency. These limitations lead us to ask, is it possible to generate more creative image without changing the model architecture or retraining the model? That question became the foundation of our research. Various methods have been proposed to guide creative generation in generative models. Broadly speaking, these approaches can be categorized into two types. First, combinatorial approaches, which generate double outputs by recombining known concepts in unconventional ways. Second, exploratory approaches, which aims to discover entirely new concepts by exploring regions in a concept space that are distinct from existing ones. However, most of these prior methods come with limitations that they typically require additional datasets, retraining, or customized learning objectives. In contrast, we aim to develop a method that enhances creative generation based on a pre-trained Stable Diffusion model without requiring any additional data or retraining. As a first step toward enhancing creative generation, we explore the simple intervention, amplifying the internal feature maps of the model at the block level, only when the prompt includes the creative. Stable Diffusion model follows a unit architecture which consists of a down block, middle block, and an up block. Through our experiments, we observed that amplifying feature maps in the down and middle block tends to enhance creative visual traits in the output image. However, we also encountered an issue. When amplifying only feature maps, particularly those in the first down block, the resulting images often exhibit mosaic-like artifacts or noise. So we hypothesized that this was due to excessive amplification of high-frequency components in the feature maps. To address this, we decompose the feature maps into their frequency components and selectively amplify only the low-frequency signals. As a result, the artifacts were significantly reduced and the image retained a more natural appearance while still enhancing creativity. This process is illustrated in the diagram shown here. In our method, we operate on the earlier blocks of the pre-trained model, specifically the down blocks and the middle block. For each feature map, we first transform it into the Fourier domain to obtain its frequency components. We then selectively amplify only the low-frequency components, and after that we apply an inverse Fourier transform to bring the feature map back into the original spatial domain and continue with the standard image generation process. By amplifying only the low-frequency signals in this way, we are able to generate images that are not only more creative, but also exhibit structurally unique characteristics. We refer to our proposed method as C3, short for Creative Concept Catalyst. As shown on the right, our method produces a building image that is more creative and architecturally distinct compared to the baseline image on the left, generated without any modification. However, one challenge remains. The optimal amplification strength varies across blocks. If the amplification is too strong, the image may become distorted or lose semantic coherence. On the other hand, if it is too weak, the resulting image may not exhibit any noticeable creative enhancements. This raises the key question for us. How should we determine the appropriate amplification value for each block? In other words, which criteria should guide the tuning of creativity? In general, creativity is evaluated based on two core dimensions, novelty and usability. We assume that novelty tends to increase naturally as the amplification grows. Therefore, the ideal setting would be the points where novelty is maximized under the constraint that usability remains above a certain threshold. This leads us to define two practical conditions for measure usability in image generation. First, the semantic meaning of the target object should be preserved. Second, the image should maintain a high level of visual quality or aesthetic appeal. Based on this, we adopt the following metric. Click score to evaluate how well the object's semantic meaning is preserved. Aesthetic score based on a learned aesthetic prediction model to quantify visual quality. We formalize this process as follows. First, we define a unified metric called the usability score, which is computed as the sum of the clip score and the aesthetic score. Next, we perform a line search to find the maximum amplification values that satisfy the following constraints. The usability score must remain at least epsilon times that of the original image. Here, epsilon is a hyperparameter that controls how much we are willing to compromise on usability. When it is large, usability is better preserved, but novelty may improve only slightly. When it is small, novelty can increase more, but at the cost of greater usability degradation. Therefore, epsilon plays a crucial role in balancing between novelty and usability, and serve as a tunable parameter that governs the trade-off between creative exploration and practical relevance. Here, you can see three sets of results from left to right. The leftmost three rows show images generated by the baseline model using the prompts with just the added word creative. The middle three rows show images generated using our method with the same random seeds. As you can see, our method leads to outputs that exhibit more pronounced creative characteristics while still maintaining the core identity of the objects. The rightmost three rows show generation from Concept Lab, a recent method we used for comparison. While Concept Lab performs well when the prompt involves higher level categories like pets or furniture, we found that it sometimes struggles with fine-grained categories such as chairs or cars, often producing images that deviate from the core semantics of the target objects. The quantitative results are summarized in the table shown here. To assess how novel the generated images are, we computed two widely used distribution-based metrics, FID and precision. Importantly, the reference set for these metrics was not the training data, but rather a baseline set of images generated without the word creative in the prompt. In other words, FID and precision here measure how distributionally different the generations with the creative prompts are compared to the original generations. Across all settings, our method produced images that were more distributionally distinct, indicating a clear increase in novelty. Next, we evaluated semantic alignment between the generated image and the text prompt using the click score. And additionally, we used a visual question answering model, BLE, to check whether the generated image actually depicts the intended objects described in the prompt. The results show that our method preserves semantic meaning of the target more reliably than the baseline without significant performance degradations, and perform more consistently than the comparison method, concept lab. To further evaluate novelty and usability from a human perception perspective, we conducted a user study. Participants were shown sets of images generated by 3 different methods: the baseline generation, our proposed method, and the comparison method. For each image, they rated novelty and usability on a 5-point Likert scale. The results were consistent with our quantitative findings. While usability showed a slight decrease, the improvement in novelty was significantly pronounced, highlighting the effectiveness of our method in generating images that are perceived as more creative by humans. Our method is also compatible with existing hyperparameters commonly used in text-to-image generation, such as classifier-free guidance and negative prompts. When combined with these techniques, it can further enhance the model's creative generation capabilities. Moreover, our approach is also fully compatible with ControlNet, which enables generation conditioned on additional inputs such as canny edges, depth maps, or pose estimations. This flexibility allows our method to be seamlessly integrated into a wide range of conditional generating settings, making it broadly applicable across diverse use cases in creative image synthesis. However, our method also has a few limitations. First, while it promotes visual creativity, it does not explicitly account for functional usability. As shown in the examples on the left, some images may appear creative, but would be impractical or unsuitable for real-world use. Second, our method relies on expressive capacity of the pre-trained generative models. As a result, the diversity of creativity is inherently limited by the scope and biases of the model's training data. If certain concepts or design patterns were underrepresented during training, the model may struggle to explore novel directions in those areas. To summarize, we propose a method, Creative Concept Catalyst, to enhance creative generation in pre-trained Stable Diffusion model by amplifying low-frequency feature maps in the earlier blocks without requiring any additional data or retraining. Building on the definition of creativity as a balance between novelty and usability, we introduce a framework to search for optimal amplification values per block. This allows us to increase creativity while preserving the semantic meaning of generated contents. Extensive experiments, both quantitative and qualitative ways, demonstrate that our method effectively encourages creativity while maintaining meaningful and high-quality outputs. Thank you.